The population of Stanitsa Kushchovskaya, Krasnodar territory, is 30,000. The first-class accommodations, making about 40%, are connected to the centralized drainage system, while more than 60% of the residents have their own dwellings whose sewage is drained into septic tanks and then taken by cesspool trucks to sewage wells. The Stanitsa has over 800 small livestock enterprises whose sewage is also driven to the sewer system. The sewage produced by 2 sewer stations is driven via 2 6.5-meter-long flow lines of 300 mm diameter to the sewage purification plants of 2.7 thousand cubic meters per day capacity. Due to the long stay of the sewage in the septic tanks, the sewage pumping station, the automatic and discharge flow tanks, as well as the sewage arriving from the farm, the organic impurities reach 400 mg per 1 cubic decimeter, and the ammonia nitrogen reaches 170 mg per 1 cubic decimeter, which 8 times exceeds the calculated content. The work of the treatment plant is complicated by the low-temperature sewage arriving here in winter. This temperature falls down to 7–8 degrees centigrade, which almost stops the biochemical reaction. The sewer system produces leavenous poison, sulfuretted hydrogen and hydrosulfides, their winter concentration making 4 to 5 mg per 1 cubic decimeter, which is 4 times greater than the admissible value. In spring, as the groundwater rises, the septic tank's content is intensively carried away, which raises the concentration up to 30–40 mg per cubic decimeter. In summer, as the sewage temperature rises, the content of sulfuretted hydrogen and hydrosulfides ranges between 16 and 20 mg per 1 cubic decimeter. The existing traditional aeration plants fail to provide efficient purification under the said conditions. In accordance with the technology developed by Rostov Public Service Research Institution, the sewage is first purified in the 2 mm mesh fine mechanical cleaning grade, manufactured by the Riotech company. They are started automatically with the rise of the filtering resistance. The quart waste is driven to the conveyor, switched on after established intervals, and then the waste is dumped into the container. Then starts mechanical purification. Sand is caught by a vertical sand catcher of a simple and efficient design, equipped with a hydraulic elevator transmitting sand pulp to sand platforms. As a result of long investigations, we have developed a special technology of inhibitory effect of sulfuretted hydrogen, assisted by hydrogen peroxide. After that, the sewage is driven to the mixing chamber, together with the sludge mixture from the combined installation's air packs. Then, the sewage and sludge mixture is pumped by circulators, which function automatically, switching on and off the main and standby units after preset periods of 20 hours, and in case of emergency, it is driven to the biofilter irrigating systems. Biofilters, having horizontal corrugated asbestos cement sheets inside them, absorb and oxidize 60 to 70% of their organic impurities and partially denitrify 10 to 15% of the above. Using these installations, we test various horizontal sheets made of ceramic plastic, glass-reinforced plastic, and glass-reinforced plastic with ultrasound-sputtered metals and metalloids, favoring electrostatic attraction of the biomass. It is only in the biofilters that the sulfuretted hydrogen is blown away due to irrigation and film contact with the sheets. As the liquid flows in a foam, it is saturated with air oxygen. The biofilters thus form the biomass that sorbs and oxidizes hydrosulfides. The rest part, that is between 30 and 40% of the organic impurities, are oxidized and the ammonia nitrogen nitrified in the reaction zones of the air packs. The sludge mixture is additionally saturated with oxygen and the aeration zones. Content mixed due to shock, air bubble float and hydrodynamic flow movement with the help of aeration towers, 0.5 to 0.6 cubic meters of air per 1 cubic meter of circulating liquid. The towers are adjusted 2.2 meters higher than the liquid surface, and their embedding under the water level is 3.5 meters. The arriving liquid forces the sludge mixture out to the setting zones, where the sludge is separated from the water due to sedimentation. Sludge flakes settle down back to the aeration zone. Pure water is driven away through collecting trays. After that, the water is driven to the ultraviolet disinfecting plants, switching on automatically as the sewage arrives. We have designed a block, switching on a definite number of lamps, depending upon the consumption. The combined installations are blocked together with the administrative and welfare rooms and the laboratory. The shown technology reduces power consumption 3 times. The constant power flow needed for the work of 2 circulating pumps is 28 kilowatts per hour, while the traditional aerators consume more than 80 kilowatts per hour for the blowers and pumps. Since we have enclosed installations and the biochemistry process needs minimum outer air, 4 times less, and there are heaters, the temperature of the treated sewage in winter rises by 2 degrees, while in the existing aerators it falls by 2 to 5 degrees centigrade. Enclosed type installations and minimum use of the outer air enable to decrease the heating of the liquid, which is relevant for the countries of hot climate. This secures steady purification in winter. As the biofilter biocenosis stays vital for long, the active biomass is quickly recovered in case the idle time makes more than 3 to 10 hours. Availability of free spaces enables to use as advanced treatment facilities biological ponds with higher aquatic vegetation. These ponds are also used for fish farming. Further on, the water is driven to the river named Yeya.